Welcome back. Now that we know how to solve our exponentials using our equality property, we're going to switch it up again, just like we did with logs. What happens if my exponential equals a number instead of another exponential? Okay, starting out really basic, we're looking here at 2 to the x equals 16. This one's easy because we should know how to figure that one out. We know 2 times 2 times 2 times 2 is 16. So this is 2 to the 4th equals 16, so we know x equals 4. If they're nice numbers like that, it's easy to figure out. We know how to do that. That's pretty basic. But what happens here? 2 times itself how many times is going to equal 15? Well, I know that number is going to be slightly lower than the 4, but what is that number? This is where logs come into play. If you remember solving our log equations, we had to rewrite it in exponential form to be able to solve it. Well, now it's in exponential form. My unknown is my exponent. I need to rewrite this as a logarithm so I can solve it. So what this becomes is log base 2 of 15 equals x. And right now that doesn't really tell us a whole lot. I don't know what that number is still. But if the question says solve the logarithm, to solve the logarithm, I'm going to isolate my variable. Well, I've isolated it. I'm done. This is what we would call our exact solution. No rounding, no error. That's my answer. In my next video, I'm going to show you how to take this exact solution and find the rounded solution. So we're going to put pause on that. We're just going to practice solving for now. Okay, our goal when we're solving these is we need to have our exponent equal a number here. So my first step I want to make sure is we isolate the exponential, or we isolate the piece that has that base with the exponent. So here I need to isolate my 3 to the x. So I'm going to add 4 to both sides. So I get 3 to the x equals 12, which means 3 to what power equals 12? I don't know. So I rewrite this as a log. Log base 3 of 12 equals x. Again, this is my exact answer. Next video, we'll take that to a decimal. So once we isolate the base, we are ready to rewrite as a log. That's our goal. Okay? Cool? Yes? So these next two examples just add in some algebra. More steps, but the process itself is the same. The only thing that's changing is the algebra. So my goal here is I need to isolate my base. So I'm going to subtract 1. So I get 2 times 5 to the 3x equals 16. I'm going to divide by 2. So that gives me 5 to the 3x equals 8. I've now isolated my base, so I'm ready to rewrite it as a log. Log base 5 of 8 equals 3x. And now I'm going to isolate my x by dividing by 3. So x equals the log base 5 of 8 over 3. There's my exact answer. Here in a minute, we will learn how to take that to a decimal. But all I'm doing is isolating my variable, calling it good. So if you want, go ahead and hit pause, try this next video or this next problem, come back, see how you did. All right, so I'm going to isolate my base here, which is my 9. So I'm going to add 2. So 7 times 9 to the 4x plus 3 equals 17. Divide both sides by 7. So 9 to the 4x plus 3 equals 17 over 7. Rewrite that as a log, so log base 9, 17 over 7 equals 4x plus 3. Now I need to isolate the x, so I'm going to subtract 3 from both sides. Log base 9 of 17 over 7 minus 3 equals 4x. And my last final step is to divide by 4. So x equals log base 9 of 17 over 7 minus 3 all divided by 4. Okay, good luck. If you got questions, let me know.